Okay, Shay, in our last class and rest of the students, we were doing the rate of the reaction, and we are still doing the question. We are still doing the literature of this chapter. Meanwhile, we have already shared the Drive folder link for in which you will check out the recorded lectures of the previous classes, and will also include the topical worksheets which I have compiled by myself for the question 2022 to 2016, like from 16 to 22. You will have to practice those questions, and it will be preferable if you get the printout of those topic worksheets in the hard form. And that drive folder will also contain the revision notes, the revision which the same note which you are looking at the screen. So the same PDF file has been uploaded in the same Google Drive link. So you are supposed to now go through the review notes, do some questions, and collect some of the difficult questions for me to discuss with you during the class. That's how the strategy is done. How we will like progress in our future. You will uh, you will listen to lectures, you will revise the notes, you will attempt the question, and you will tell me the difficult question. That's how you will have a complete command on a specific topic. Is that clear? Okay. We were doing the effect of the temperature on the rate of the reaction. In this topic, it states that the shape of the maximum Boltzmann distribution curve, which you studied in AS, also indicated the effect of the temperature on the rate of the reaction. If you remember the shape of the Boltzmann curve, do you remember how it looked like? There is a long tail, then there is an inclined peak, and then it decreases. So it was like this curve. It was called the Boltzmann distribution curve or Maxwell-Boltzmann curve. Yeah, there is also an activation energy. It can be somewhere here. It can be here. And this whole peak represents the number of the molecules or population of the molecules. Number of molecules on the y-axis, and on the x-axis, we can indicate the catalyst. We can indicate the activation energy, and this indicates the energy. The x-axis indicates the energy, whereas the y indicates the number of molecules. So we also studied in the same AS that when we increase the temperature, what change do you observe when we increase the temperature for this maximal curve? It will come down. Right, exactly. The peak will shift to the right and it will be lower down. So I can say it will be like it will be lower down, and the peak will shift to the lower position. The page is ending over there. That's why I have to decline it uh, very sharply, but it should be like decreasing smoothly like this. So this indicated that if we increase the temperature, then we are basically having more molecules which have energy equal to and greater than the activation energy. So it is showing here that we did discuss this in the AS as well. Then if the rate of the reaction, if the rate increases as the temperature increases, then so must the value of the rate constant K. The rate constant K, again, it comes from this expression. If we want to find the value of K, then K will become rate divided by concentration of the substance, the reactants here. So as we say that the rate is increasing by increasing the temperature, then it also means that we have an increased value of K. So it is linked with the same thing. If the increased temperature increases the rate, so this whole expression will have larger value, and that's how the value of K will also increase. So there is a direct relation between them. Is that clear? All right. Now, the relationship is not linear one. However, experiments have shown that it is an exponential relationship. It is also found that the dependence of the rate of the reaction on the temperature hinges on the value of the activation energy. The larger EA is the greater the dependence of the rate on the temperature. Basically, as we saw here, that increasing the temperature is not uh, as simple as it looks here. We have to consider a graph in which the rate of the temperature is depending, and the rate of the temperature is affecting the rate of the increased temperature is affecting the rate of the reaction. But we are not going to discuss that graph here because it is not included in our syllabus. We just learn to know that the temperature will definitely increase the rate of the reaction. I hope it's clear. Okay. Then we have uh, another topic to deduce the order of the reaction from the raw data, which means we will be provided some of the tabular form of the data, and we have to check how this data is basically uh, helping us to find the rate of the reaction. In this case, we have to select one row at a time, and we have to select two rows at a time, two rows. Those two rows in which only one reactant will be changing its value or changing its concentration, and the other reactant will have constant value. One of the reactant must be changing, but the rest of the other reactant must not be changed, it will be fixed. So we have to select those two rows at a time. In this method, sorry, yes, exactly, we can take I don't know why it's not highlighting properly. So let's suppose we have the HCl, propylene, and iodine. There are three reactants. Within this case, if we take first and second example, the experiment number 1 and 2, which two in experiment 1 and 2, which reactants are showing constant value? The propylene. You can see they are constant in experiment 1 and experiment 2. Is that clear? What about the iodine? It is also fixed. It is not changing. So basically, we have selected experiment 1 and 2 just to check how the change in concentration of HCl will affect the change in the rate of the reaction. To find out the change, we have to see what is happening before experiment 1 to experiment 2, and what is happening in from experiment 1 to experiment 2 in case of the rate. Is it increasing or decreasing? No, the concentration. The concentration is decreasing. Okay. So for our simplicity, we will basically consider the reverse case. We will see what will be the change in the concentration of HCl when we move from experiment 2 to experiment 1. It is the increase. So increase in concentration over here, and also an increase in the rate of the reaction. That is clear now. But how much? We have to check that. Let's suppose we are taking the concentration values first. I have to check that 1.25 divided by 0.625 will give me an answer of the increase in the concentration. So I can calculate this value on my calculator. So 1.25 divided by 0.625 give me an answer of 0.1.25 divided by 0.625. If it gives me an answer of 2. Okay. Now I have to apply the same calculation on the rate of the reaction. which means I will take larger value in the numerator, 10.9 divided by 5.4. 10.9 divided by 5.4. It gives me a value of 2.018, which is again approximately equal to 2. So you can see clearly that by increasing the concentration of the HCl, the rate of the reaction has increased by, by doubling the concentration of the HCl, the rate of the reaction has also doubled. So both the rate of the reaction is doubling as well as the concentration is doubling, which indicates that this rate of the reaction is directly proportional to the first order of the reaction with respect to HCl. So I will say that this rate is directly proportional to the first order of the HCl. And you know that the value over here is understood to be 1. So it is first order with respect to HCl. So we have found the effect of one reactant at this time. Now we have to check other reactant by considering the other two reactants to be constant. So here, let's check the, which example do you want to consider now? Which experiments? Do you want to check propanone or iodine? Okay, let's take iodine, which means you have to keep these two. You have to keep these two as constants. Okay, here, sorry. So if you're checking the propanone, then for HCl to be constant, we have experiment 1, 3, 4, which shows in constant values, and from iodine we have all of these as constant values. So which two are matching? 1 and 4. These two are matching. 1, not 1 and 4, 1 and 3. We have to check we have to check propanone. You are saying propanone. Did you say propanone or iodine? Iodine, okay. If you want to check iodine, then I have to check the constant values for HCl and propanone. For HCl, I have these constant values, and for propanone, I have these constant values. Now, which two are showing the same? 1 and 4. All right. Now, 1 and 4 are constant values, which means I have these values of the iodine 1.25 and the other one is 0.625. So if you go from experiment 4 to experiment number 1, it will give you the same calculation here, that it is increasing by 2. So it is basically doubling the concentration of the reactant. On the other hand, if you check the increase in the rate, so you're going from 10.7 to 10.9. All right. 10.7 to 10.9. Do you see any difference here? Okay. How much difference are you looking at? 10.9 divided by 10.7 wouldn't be equal to almost very close to 1. It will be very close to 1. Whenever we have a value of 1, which means the rate is increased by 1, it means that the that the rate is proportional to anything which comes in the square bracket. Let's suppose here it is the iodine. It shall have which value on it? Over here. To get a value of 1, what should be the order here? Anything having a power of 0 gives a value of 1. So it is 0 here. That's how you are getting 1 here. Which means this rate is independent of the concentration of the iodine. Iodine has no effect on the rate of the reaction. the order of the iodine is 0. 0 order with respect to iodine. Now we have to check for the third reactant here. The third reactant in this case is the propanone. We have checked with respect to HCl, with respect to iodine, but we are now left with propanone. For propanone, we have to keep the other two as constant values. 1.25, all of these are 1.25 constant values. From here we have 1.25, 1.25, 1.25. So which two reactants experiment can we take? 1 and 3. Good. So now again check the change from 0.25 to 0.5. It's a change of how much? If you move from 0.25 to 0.5, it is a change of double. It changes by 2 times. Okay. Now again for check for the rate of the reaction, you are moving from 5.1 to 10.9. So how much change do you see here? 10.9 divided by 5.1. Simple maths. No, 2. Yes, 2. Very good. It's very much closer to the value of 2. That is 2.13. 7 nearly equal to 2. So which means that if we increase the concentration by 2 times of propanone, the rate of reaction is increasing by 2 times. So it is directly proportional, which means it is of which order? First order. Very good. So propanone is also a first order here. Rate is directly proportional to for propanone. I will just write PR here. It means propanone. It is first order. So now we have calculated the orders of all the 3 reactants. First order with respect to propanone, first order with respect to HCl, and 0 order with respect to iodine. So my next question is that what is the overall order of the reaction? 2. Because you have to combine all the reactants here. We will add all of them. So rate is directly proportional to iodine is 0, HCl is 1, propanone is 1. So overall order is 2. Is that clear? All right. So that's all for today. I will continue from this topic and by taking another example. Inshallah. Take care. Allah Hafiz.